Pamela are about to have an adventure.
This is our room.
Oh, okay. All right, room number 17.
They're headed out from the University of Washington for 3 weeks at sea.
Jeez!
This is a research ship, and they'll be studying underwater volcanoes known as black smokers.
It should be really interesting to see.
It's very exciting because it's still an environment that's not very well known. It's also very exciting because there's still an exploratory aspect to the work that we do.
This deep sea research involves a team of geologists, oceanographers, chemists, and physicists. And biologists too, because there's some cool life around those volcanoes.
We are continuously making new discoveries because this is really still a frontier on our planet that we don't understand very well.
And that's one of the things that makes science exciting.
The thrill of discovery, and that involves a lot of fun things. It involves working with really smart people in a kind of a team-based setting oftentimes. And there's an adrenaline rush associated with it where you think, you've made a big breakthrough or you're on the path to a breakthrough.
Or you could design something that makes a major impact.
Maybe I'll help Microsoft make software or something. They'll design it.
It's the adventuresome life. Science and engineering are for those that have the adventuresome spirit. I got to work on the space shuttle design. I was one of the designers of the F-14. I'm very proud of that. Yes, it was hard work, but it was like going to work and seeing a new adventure every day.
That's what Dahlia Chavez hopes to do. She's planning to major in electrical engineering because she wants to create things.
Yeah, that's the kind of science I want to do. I don't want to just sit at, somewhere and just watch. I want to do something where I could actually, use my hands to fix or something, or design something.
At the University of Washington, she might design something that actually sells.
That's something that happens a lot in engineering, is that students and faculty come up with inventions that then we pursue those with our Office of Technology Transfer, and some of them get patented and licensed and used by other companies for commercialization purposes.
And once you're out on your own, you could make a ton of money.
People in science and engineering do very well when it comes to salary from a lot of different angles. They make a very good salary to begin with, but they're working usually in higher tech companies and industries where stocks, do very well.
You could do research, start your own business, or work for one of the hottest technology companies. For some students, like Fred Stevens, science is all about helping people. That's why he's planning to go into medicine.
Well, it's just something that I've always wanted to do from when I was a little kid. I had the little doctor kit and everything, and I've always been interested in science, so coming to the biology department was something that fit me perfectly.
Fred's a freshman at the University of Washington. He chose the UW because it's close to home and because of its reputation. The University of Washington is a leading-edge university. It has more research funding than any other public school, and it's ranked with the very best universities in the country. A degree from the UW has prestige, and it gives an advantage when it's time to apply for graduate school or start a career.
These students that come to the University of Washington, earn their bachelor's degree, find out that it's worth so much. The very top engineering and science companies come here. They don't go to every school, but they come to the University of Washington.
Summer internships at the UW give you a jump on college, and you might get a better idea of what you'd really like to do.
The internships are important because it gives us a hands-on feel on the lab, something that we've never really experienced. Like, people always say they want to do stuff, but you don't really know what it is until you've done it, and the internships give us really, really good hands-on experience in our field.
The University of Washington offers summer internships in science, technology, engineering, and math. These STEM internships are available to students in high school or community college, and also to UW freshmen or sophomores. Interns do research at the university or work in local companies. Workshops and seminars help build their skills.
I thought that chemistry, there's so much stuff happening all the time, especially medical, and so maybe I'd get into that and research. And this is a major research university, and I just thought it'd be a really good way to get introduced to different fields and things.
This could be our lunch for today.
STEM internships are open to any student interested in science, technology, engineering, or math. And that includes people with disabilities, today's technology has made so many careers in those fields possible. Imka Dura, who is blind, is just finishing graduate school and heading for a career in atmospheric science.
At about age 12 or so, I decided that maybe I should go into something related to weather, and it never changed.
At the UW, the Disabled Student Services Office is available to help students with disabilities plan their accommodations. In Imka's case, that meant putting textbooks into Braille or on the computer.
The support you get at the school through the Disability Services Office is crucial, because the best department in your field doesn't help if you can't get the text in the right format.
And if you need some extra academic help making the jump to a university, check out the Office of Minority Affairs Bridge program at the UW. It's so worth it.
We spent 3 weeks on campus, living in the dorms, attending college classes. It was a really rigorous program. It was really structured, really scheduled, and it was a lot of fun. It basically bridged the gap between high school and college.
Well, myself, I met a lot of people, and that really helped because everybody that I met pretty much talked to now, really close friends. It's kind of like a family. We call ourselves a bridge family.
And you'll have fun. In the summer, Jean Magallanes uses salsa dancing to help students get over any fear of math.
The difficulty is an illusion. 4 or 5 basic steps put in different combinations result in a beautiful exhibition. Mathematics is very similar. 4 or 5 basic rules put together in different combinations will give you a fundamental understanding of math that will take you to careers in science and engineering.
Once you're in college, you'll find as much support as you need.
Go down to the bottom.
There are hundreds of social, political, and professional groups on campus where you can connect with people. Dakota, for example, is a member of ACES. That stands for
American Indian Science and Engineering Society. I got involved with that, first of all, because I'm an engineer, or I wanted to become an engineer, and also I'm a Native American. And I just wanted, first of all, to get to know my own, see if there's any other people out there like me.
Can I grab another bottle, or?
You'll get support from your professors, too. All you have to do is ask.
The university is very supportive, and there are a lot of opportunities for funding, working with professors, support groups like for women in engineering. So there's a lot of things that you can tap into that can help you through the whole process.
Accelerate with your legs.
And while you're busy succeeding in your major, you can enjoy all the other great things that the University of Washington has to offer.
It's important to study and do well in your classes, but there's so much more than that. There's student societies, sports. I was on the crew team. There's just so many fun things to do, and
there's so much to learn, so much to do, so much to gain. Actually, there are a lot of things out there. If you want to find something, there's something out there for you, basically. There's something out there for you.
And who knows what that might be? There are so many opportunities, so many options at the University of Washington. Science, technology, engineering, and math. They can start you on a lifetime of adventure.
And that's what keeps us going. That's really the exciting part, is that we just don't know where we're going. And so we're inventing things as we go along and asking more questions all the time. So it's, I think, anybody that's curious about anything should be interested in science, because that's what it's all about.
Hi. Welcome to Mainstream High School.
It's nice to be here.
Well, we've got a special area set up just for you right over there. Hi. This is Angelica. She's your classroom buddy. She's going to help you figure things out.
Oh, great.
Let's go. So, have you always been a cripple?
Oh. We don't say the word cripple or crippled. It's handicapped. He's handicapped.
Oops.
Now, what we're trying to represent here, class, and you remember the equation from yesterday, the surface area of a radio wave is... By the way, can you see okay? Huh?
Yeah.
Okay, you let me know if you need any help, all righty? All right. So anyway, I'm Pat Cashman. Okay, I'll admit maybe we were exaggerating a bit there, but the point is if you have a disability, you face a lot more than just physical barriers. The way people look at you, the assumptions they make about your abilities. That can be a lot tougher thing to deal with sometimes than the disability itself.
Folks who are blind tell you that people often yell at them, as if somehow because you can't see, you can't hear. And it isn't unusual for folks to use expanded speech to talk slowly to people. That somehow people think that your disability kind of ends up taking over who you are.
It's important to put the person first, even in speech. Referring to a student with a disability is preferable to saying disabled student, and avoid words like crippled or handicapped.
I think what you do is you focus on the student rather than on the disability. I mean, why judge the student 100% for something that really only affects 10% of how they function?
Hi. Are you logging in okay? Are you getting access?
Most people aren't totally insensitive. They just haven't thought about it. Or maybe they've thought about it too much, worried a lot, and ended up being too protective.
It was my second year of teaching. I had a student, and she was lovely, but I was so afraid of her. I was so afraid that something would happen, and she would, she had a seizures disability, I guess, and I was just terrified that I was going to set her off. And so looking back, I kind of regret it because I treated her like spun glass, you know, like she was so fragile.
Often, expectations are lower for students with disabilities. The chair, the crutches, or the white cane can obscure a student's real talents or personality. If you ask Marissa about herself, her disability is a small part of who she is. Her passion is writing.
Mostly poetry. I love poetry. I love to write it, and I've entered many poetry contests, and not most, but like a few of my poems have been published.
Marissa's a junior in high school. What she expects from her teachers isn't much different from any other student.
Just accessibility in classroom and
be finding the averages
and respect, like other kids get from their teachers.
She gets a lot of respect from her math teacher, Sherry Smith. After 11 years of teaching, Sherry still learns from her students.
Marissa had some difficulty with her hands, but I, at the beginning of the year, assumed that meant a whole range of activities was not available to her, and she has really proven me wrong. And I think that looking back, if there's one thing that I would change for next year, it's letting them decide and tell me what they can't do, rather than making an assumption based on something that I observed. I mean, that's ideally what we look for in all our students, all the kids, is to let them reach as high as they can reach and not stand in their way.
Not standing in their way means that kids need to be able to get into classrooms and science labs, understand the information offered, and participate in all activities. Physical, sensory, or learning disabilities may require accommodations to make that possible. Those accommodations are often quite simple.
0 plus 3 plus 3 plus 0.
Getting the student to class may involve accommodations, such as accessible location, a table instead of a desk, or seating near the front of the class for someone with low vision. In a science class, lab equipment might have to be placed at an accessible level.
you have to think about the physical things. I mean, the physical plant. I mean, you don't realize how tall those lab tables are until you're sitting at a chair and you can't reach the top.
A lot of what makes a class accessible to any student is the teacher.
Now let's talk about how we represent a circle here. Now, we write A here for area.
Poor teaching techniques are going to shortchange everyone. Talking to the blackboard instead of the class, speaking too rapidly or too quietly, and failing to engage students in the learning process will be detrimental to everyone in your class, including students with disabilities.
We start with the area here. That represents the area between, say, just west of Kansas, east of this area. Pi r squared. Now, is that perfectly clear to anybody? If there are any questions, I'd like to hear them.
Speaking clearly and facing the class makes instruction easier for every student, with or without disabilities.
Right.
Well, maybe not every student.
I've found that one of the things that I need to do for certain students is to be more organized, and it's not fair to them to not be organized when they need that. They need it typed out, or they need to be able to come to me and say, okay, I didn't get everything you said. Can you show me something that I can write down? Can you make a copy of something for me to have?
Compare your slime to your gap.
Young people have to learn to advocate for themselves. But as a teacher, it's also your attitude, your lesson modifications, and your teaching strategies that will help students with disabilities succeed. Here are some suggestions for
Have
you.
you working on it?
For a student with a mobility impairment, a note taker or a copy of your lecture outline. Test-taking alternatives, such as dictating to a scribe, using a computer, or extra time on tests. A lab assistant or group lab assignments. For a student with a hearing impairment, face the class when speaking. Give out written assignments, lab instructions, and demonstration summaries. Use open-captioned videos or slides, or provide a written summary of the material covered. Repeat questions from the class before answering them. Work with an interpreter or note-taker. For a student with a visual impairment, use enlarged print, audio tape, or an electronic format for handouts and texts. Write in large print when using the chalkboard. Allow tape recording of classes. Give extra time for research or tests, or make alternative test-taking arrangements. For students with learning disabilities, consider extra time for reading and writing assignments, as well as tests. Provide oral exams if necessary. Allow tape recording of lectures. Use visual, oral, and tactile demonstrations.
What you wind up doing is bend the whole hull and everything is moving around in there and you lose the alignment on your chain. And
Remember that each student is unique, and so is every disability. Before making these lesson modifications, ask questions. Let your students tell you what they need and don't need.
In fact, now, rather than taking care of their every need before they even see it coming, I'm much more likely to let them reach the moment and try to solve it for themselves. And respecting their strengths is a difference between now and when I first began.
Science classes, in particular, may require additional accommodations, especially when lab work is involved. To help your students participate fully, you might want to start with this classroom accommodation model. Step 1. What does the task or assignment require? Step 2. What physical, sensory, and cognitive skills are needed? Step 3. What components of the task require accommodation? Step 4. What accommodation options exist? Here's the accommodation model in action. In chemistry class, Kathy Metcalf wants her students to perform an acid-base titration. In Step 1, break down the experiment into separate components. Determine the specific tools and tasks required at each step. Here, students have to set up a stand, pour liquid into various containers, including a burette, clamp the burette into place, open and close the valve, swirl liquid in a beaker, read measurements, observe color changes, and record data. In Step 2, match each of the tools and tasks to the physical, sensory, and cognitive skills needed. Some of the physical skills needed for titration include grasping containers and pouring liquids, manipulating the clamp to hold the burette, turning the knob to open and close the valve, and swirling the liquid in the beaker. Sensory skills involve seeing a color change from clear to pink. Cognitive skills involve determining measurements and recording data. In step 3, determine what accommodations might be needed, or if the lesson plan could be altered to make the task more accessible. In this case, some possible accommodations include a funnel for pouring, plastic instead of glassware, a burette with a squeeze valve, and a pre-printed large type data table for recording observations. A lab assistant or partner could describe color changes. Observations could be tape recorded for transcription later. Discuss accommodations with your student. In some situations, you may want to consider educational computer software.
There are alternatives available, and a lot of them aren't that expensive. Buying some of the computer simulation software, or providing an internet access for a frog dissection if they can't physically do it. There are things out there to have access to so that the student has a similar experience.
In step 4, identify resources for necessary accommodations. Students, staff, and professional groups may be helpful.
Each student can participate to a certain degree, and I think that's again what you do with the student who has a disability. You determine to which degree they can participate in. It's going to be most inclusive for them, and it's going to give them the most knowledge.
Are you answering the questions okay on number 6?
And remember, making accommodations does not mean lowering expectations.
It's the faculty member's responsibility, if he really or she really has respect for the student, to have the same expectations for that student's academic performance that he or she would for any student.
And that helps students with their own expectations. Marissa's excited about college, where she plans to study computer science and creative writing. She can't wait to get out on her own.
My mom would probably want me to stay close to home, but I want to go somewhere big that I've never been before.
Teaching students with disabilities really gets down to common sense, sensitivity, and your own willingness to listen. Students can really be your best resources for this. They're the experts on accommodations. For more information or additional resources, contact DoIT.
On the web, www.washington.edu/DOIT. Phone, voice or TTY, 206-685-DOIT. Address, DoIT, University of Washington, Box 355670, Seattle, Washington, 98195-5670. Director Cheryl Bergstaller. This videotape was made possible as part of Project DoIT by grants from the Dwight D. Eisenhower Foundation and the National Science Foundation. The University of Washington Computing and Communications also contributed resources to this project. Copyright 1998, University of Washington.